Welcome to Calculus. Today we will investigate finding higher order derivatives, focusing on finding the first derivative and the second derivative. Let's take a look at three examples, three different types of functions. So for our first function, we're looking at a quadratic, f of x equals 3x squared plus x minus 2. And we want to begin just by taking the first derivative of this function. So we'll apply the rules that we've been using. The constant coefficient 3 will just stay put. And then applying the simple power rule to x squared, we bring the old power down as a coefficient, so 2x to the power of 2 minus 1. For the derivative of x, we know that that's just 1, and the derivative of the constant minus 2 is 0. So our simplified first derivative of f of x is 6x plus 1. We'll box that. But then we also want to take the second derivative. So it's as simple as taking the derivative of the first derivative. So now we'll work on the derivative of 6x plus 1. And I'll notate that as f double prime of x. So again, I'm just applying the same rules, but now I'm applying them to this first derivative. The derivative of 6x is going to be just 6 times 1, and the derivative of 1 is just 0. And so I see my second derivative of f of x is just simply 6. One thing to note is that when I take derivatives, the powers decrease by 1. So my first original function, f of x, was quadratic, power of 2. The derivative was linear, power of 1. And the second derivative is a constant function, power of 0. Well, let's take a look at an example that involves a product. So here my function is f of x equals x plus 5 times e to the power of x. So one thing we can do is distribute this e to the power of x through my two terms to just see that this could be written as x times e to the power of x plus 5 e to the power of x. And what that gives us is really a first term there that is itself a product. So I do need to apply the product rule to that first term. The second term I can take derivative of directly. Let's remember the product rule. So we'll use the term f of x as one of these pieces of x times e to the power of x. So let's start off by defining those pieces. So this is a different f of x from my original function. I'm using this just to label the piece, the factor x. And then I'm going to call e to the power of x g of x. So let's remember the product rule, and then we'll apply it to this particular function. Product rule says the derivative of, well, if I define big F of x as f of x times g of x, the derivative of big F of x is f of x times the derivative of g of x plus g of x times the derivative of f of x. So as you can see, I do need to take the derivative of the two pieces to apply the product rule. So my derivative of f of x, if the original is just x, is going to be 1. My derivative of e to the power of x, which I'm representing as g of x, is itself. Remember, that's that unique function that is its own derivative. So I'm ready to fill in the parts for this first term of my function. So I'm going to start writing the first derivative of f of x is going to be, according to this pattern, f of x, which is x, times the derivative of g, which is e to the power of x, plus the derivative, plus g of x, which is also e to the power of x, times derivative of f, which is just 1. So that's from that first x times e to the power of x. For the second piece there, which is 5 e to the power of x, I can just apply my constant coefficient rule, so that's 5. And then e to the power of x, its derivative is also e to the power of x. I do need to combine like terms there. So I see I have an e to the power of x and 5e to the power of x. So that's going to give me my first derivative in final form will be, I'll put this e to the power of x first. I'm sorry, x times e to the power of x first plus 6 e to the power of x. For my second derivative, I can use part of what I've seen here to help me, because again, I'm taking the derivative of the first derivative. But what I notice is that I've already taken the derivative of x e to the power of x. That was that same first term from my original function. So I can just rewrite what I've done here to save myself some time. So I'll put it in the color coding. So it's x times e to the power of x plus e to the power of x times 1. Again, the derivative's given by this part of that first derivative, and I'm just repeating it here because I have the first x e to the power of x same as the original. All right, all we got to do then is take the derivative of 6 e to the power of x, and that again is just itself. 6 as a constant coefficient would just stay put. Derivative of e to the power of x is itself. So the derivative of the derivative, or the second derivative, is going to have the final form x e to the power of x plus, if I add these together, 1 e to the x plus 6 e to the x is 7 e to the power of x. So a good lesson to take from this example is that we can use parts that we've used in previous differentiation to help us as we go. Well, let's take a look at a last example that's a quotient. So here I've got the function f of x equals x squared minus 1 over x. So we do have a quotient going on. We need to apply the quotient rule. So remember how quotient rule compares to product rule. It does start off by saying, what's my two pieces? So we'll call this little one f of x. Again, that's different from my original function f of x. And that one's g of x in the denominator. So again, let's say the quotient rule. If I've got a big function, big f of x equals f of x over g of x, both lowercase, then the derivative of that big f of x is going to be the original g of x times the derivative of f of x, the one in the numerator. Here's a big difference here, minus. Remember, that's the change from the product rule. And then it subtracts f of x, the original function, times the derivative of g of x. And then also different from product rule, it has a denominator, which is g of x squared. So let's apply these two pieces and then find our first derivative. So if f of x is x squared minus 1, its derivative is going to be 2x to the power of 2 minus 1 plus 0, or just 2x. Derivative of g of x, if its original is x, will be just 1. So let's set up the first derivative of this fraction f of x. We're going to use the quotient rule. So I'm going to apply my parts there. So original g of x is x times derivative of 2x was, or I'm sorry, of f of x is 2x, minus the original f of x, which is x squared minus 1, times the derivative of g, which is just 1. And that's all over g, which is x squared. So that we need to simplify. And that's going to give me 2x squared in numerator minus x squared plus 1 all over x squared, which is going to give me x squared, if I combine those like terms, plus 1 over x squared. So let me box that as the derivative of f of x. So for our second derivative, again, I have a quotient. I can see that that first derivative is also a fraction. So again, we'll set up for quotient rule a second time, identify the same parts. So f of x is x squared plus 1, which makes its derivative 2x to the power of 2 minus 1 plus 0, or again, just 2x. So it's the same derivative as we saw in the original function. So g of x here for my second go round is going to be x squared. So its derivative is going to be also 2x to the power of 2 minus 1, or just 2x. So we're ready to find our second derivative. Let's put that in green here. And I'll do that second derivative steps here on the right. So the second derivative of x, we'll set up our fraction and put in our parts. So the original g of x is just x squared. Put that in blue. Times the derivative of f, which is 2x, minus the original f of x, which is x squared minus x squared plus 1, times the derivative of g, which is 2x. And that's all over g of x, which is x squared squared. So that again is ready to simplify. So from this first product, we get 2x to the power of 3. I'll put my minus, let's distribute here. So 2x times x squared is 2x cubed. And then 2x times the 1 is plus 2x. And I see that I can distribute that minus sign by changing both of these signs to minus. And then for my denominator, I've got x to the power of 2 squared, which is x to the power of 4. So now these two terms will cancel. So what I'm left with is negative 2x over x to the power of 4. And if I simplify that by canceling an x, I get that the second derivative of f of x is going to be negative 2 over x cubed. So notice it really reduces down to a single term, basically a monomial from those rational functions. Well, thanks for joining for this investigation of the quotient rule. I'm going to let you differentiate your own first and second derivatives. Thanks for joining. See you soon.